In this class I am discussing physical memory organization of 8086. 8086 can have 1 megabyte of total memory addressable, but this total memory address space is converted into two memory banks. One is odd memory bank and next is even memory bank. As the name says, odd memory bank is having only odd addresses 001, 003, 005 like that, only odd addresses, and even memory bank is having only even addresses 001, 000, 2, 4 like that. So if you see the diagram, for each memory, if you want to select this memory, its chip selection line should be 0 because it is a logic 0. So if you want to select this memory, a logic 0 should be sent to this chip selection, and basically this chip selection is connected to BHE of the 8086, and chip selection of even memory bank is connected to A0 address line. So if A0 is 0, this bank will be selected. So from that you understand that if your address is even, then A0 is selected by default. See, if you see in last digit of any even number, it will be 0. Okay, so if it is 2, you can convert into 0 0 0 0 0 0 1 0 8421 method. So last digit is 0. So automatically, if the total address is even, then this bank will be selected because A0 is connected here. Okay, so and if you want to select this bank, then BHE, you need to send a BHE signal. So based on that, I made a truth table based on 0 0. If 0 0, see this is BHE is 0, also A0 is 0. Both are 0 means both chip will be selected. So this memory also selected, bank also selected, this memory bank also selected. So if both memory bank is selected, you can transfer through D8 to D15, you can transfer 8 bit. For D0 to D7, you can transfer 16 bit, 8 bit. So total you can transfer a 16 bit data. So this is 8 bit data and here also 8 bit data. So total 16 bit data you can transfer. And if A0 is 1 and BHE is 0, suppose microprocessor is sending A0 is 1. So when A0 will be 1, when it is an odd address. Any odd address, if you see in binary, the last digit will be 1. That means whenever there is an odd address, this bank is not selected. If this is 1, this bank is not selected, and that is a problem. So suppose if you wanted to transfer a data from a word means what? A word means 16 bit. A word from with a starting address even, then it's very easy because whenever it is even address, A0 will be 0. Then you can send, microprocessor can send a 0 here, then both are selected. So the word data is moved to microprocessor. But this is not happening when microprocessor is acquiring data from an odd starting address. Whenever it is odd starting address, this bit will be 1. For example, 003. Let's see, 0 0 0 0 003 means 1 1. 8421 method. 2 plus 1 3. So what is last bit? Last bit is 1. So A1 is 1. A1 is 1 means this chip is not selected. So if you wanted to transfer a 16 bit data from starting address of old memory address, then there is a problem. So it need to transfer first data from the old memory bank, then it needs an additional signal and access the next location, even memory bank. So additionally one cycle is required to access old memory starting address. This is not there in the even memory address. I hope you understand. So the physically total 1 megabyte of memory divided into two banks, even memory bank and old memory bank. If the starting address of word data is even address word data transferred in one memory cycle. For even address, A0 is 0. This is the reason. But if word is stored in with the starting address old value, that means A0 is 1. By default, last bit is 1, and that is A0 is equal to 1. If A0 is 1, even memory bank not selected, so additional one cycle is required to read 16 bit from old starting address. So this is the physical memory organization of 8086, and I hope you understood what is the problem if the starting address of 16 bit data is a odd address. So it is always better to have 16 bit data starting address as even. Thank you.